Welcome to Foldit. Here we are in competition puzzle 50, strep binding. This protein is from a bacteria that causes strep throat. I'm Kathleen and it looks like I'm currently rank 84, which means I have a long way to go to get to the top. I'm competing against all these other players to fold this protein the best and get the highest score I possibly can. Now let's take a look at the protein. Note that I can rotate, translate, and zoom the camera. This thick strand that bends all around is called the backbone. Notice it's made up of helices, which are these curly spirals, and these flat sheets. When the flat sheets get close, they form hydrogen bonds. I'll talk more about hydrogen bonds later. These dangly things coming off of the backbone are called side chains. They can move into a discrete number of positions based on their molecular structure, so don't be surprised when they don't move exactly where you want them to. Now let's take a look at our tools. We were just talking about side chains, so let's look at this shake side chains tool. What it does is fixes all of the side chains at once, basically finds a good configuration for all of them such that these clashes are resolved. The main tool that we use is called the pull tool. This works by clicking and dragging on the backbone or on the side chains. There's also the rubber band tool. Right-click on a piece of the backbone and drag. It will set up this purple stick into space, which we can look at from different angles. We can also take the end of it and snap it to other pieces of the backbone. We'll set up a couple more rubber bands. The next tool is the wiggle tool. Not only does this condense these rubber bands, it also relaxes the whole backbone, basically optimizes it, finds a better position for it. Don't think of this as doing your work for you though. Wiggle can get stuck in local maximums, and also there are a lot of high-level movements that you will be able to see and execute a lot better than a computer. My goal here is to get the highest score possible. The score of this protein is calculated with the Rosetta energy function. The main thing that this score function takes into account is packing, or compactness. That is, I want the protein to take up as little volume as possible. The protein has started out kind of stretched out, so I'm going to condense it and pack it in. I'm also going to clear these logs and bands. Wiggle is going a little too slow for my taste, so I'm going to go add some rubber bands, try wiggling again, and basically get these sheets to line up and have hydrogen bonds appear in the middle. The second part of the Rosetta energy score function that's important is hydrophobic side chains and hydrophilic side chains. These orange side chains, like this one, are hydrophobic, which means they hate water. Since proteins are surrounded by water, we want to try and hide as many of those in the interior of the protein as possible. And then likewise put the blue ones, the hydrophilic side chains, on the outside. Now that I've explained a bit about the game, I'm going to show you on the user interface. So in addition to player competition lists, we have the groups. There's also chat. And down here, the undo panel, the handy restored and best, the view, which can make your protein look a lot less complicated and scary, and clear those locks. And finally, switch puzzle option to get back to the other competition puzzles or even the introduction puzzles, which you should definitely try if you're new to this game.